Hey guys, so this video is going to focus on how do we solve equations, and more specifically, if you take a look at the two examples that I have on the board, these are higher order equations. So if we take a look at these, I see that we have 4 terms in each one of these equations. Not only that, I see that the highest power of each of these equations is a 3. So that presents a couple of extra work for us to do here on how to figure out how to solve this, because we can't use regular basic solving equation skills here. So the technique that we're actually going to use in order to solve these examples specifically is we're going to factor these equations, hoping that maybe when we factor these out, it's going to make it a little bit easier for us to actually solve these. So taking a look at example A here. So I have 4 terms in this problem. There's really only one factoring technique that I know of that mainly focuses on solving equations with 4 terms in it, and that is factor by grouping. If you're not familiar with factor by grouping, please go back and watch the factor by grouping video. Otherwise, continuing on with this video here. So remember, factor by grouping, what they want you to do is they want you to split up your equation. So take 2 terms and group them together, take another 2 terms and group those together. So what I'm going to do is I'm going to group the first 2 terms of my equation, and then I'm going to group the second 2 terms of my equation. And what we're looking to do here is we want to find a greatest common factor of each one of these groupings. All right, so I'm going to specifically focus on the first 2 terms only. And we're trying to figure out what is the greatest common factor of these 2 terms. So when you're finding the greatest common factor, you want to focus on the numbers that you have first, and then focus on the variables. Focusing on the numbers 100 and 125, it looks like 25 would be a common factor for both of those, right? 25 goes into 100, 25 also goes into 125. Taking a look at my variables, I have an x cubed and I have an x squared. Remember, when it comes to greatest common factors of variables, you want to take the one with the lowest power. So since 2 is smaller than 3, I'm going to take the x squared. So my GCF for this particular grouping is 25x squared. So I'm going to go ahead and factor out that 25x squared. So that means we're pulling it out to the front. And in order to figure out what we're left with after factoring that out, we do a division here. So when we divide this out, we divide 100 divided by 25, which is 4. And then we use the quotient rule for polynomials to do the division x cubed over x squared. You drop down the x and you subtract the exponents. 3 minus 2 is equal to 1. Drop down the plus sign and do the next division. 125 divided by 25 is a 5. And x squared divided by x squared cancels out. Now, when we move over to our second grouping here, so comparing our terms here and trying to figure out what a GCF here, quickly taking a look at our numbers here, I have 4 and 5. Now, 4 and 5 does not have anything in common. When I look at the variables, we have an x over here. We don't have a variable over here attached to the 5. So there is no greatest common factor here. So it doesn't look like there's anything that I can really do with this. But that's okay, because in my first grouping, we were left with a 4x plus 5 inside our parentheses. Well, we have a 4x plus 5 already here. And when we do factor by grouping, what we're hoping to do is when we factor something out from each grouping, we're hoping to be left with the same exact factor inside those parentheses, which we have here, so it's perfectly okay. So the next step of factor by grouping tells us, well, since they both have a common factor of 4x plus 5, let's factor out our common factor one more time. So they have a 4x plus 5 in common. So I'm going to pull that 4x plus 5 out here to the front. And when I do that, we need to figure out what we're left with. So that means we divide again. We divide each grouping by our GCF, which is 4x plus 5. When we do the first division, 4x plus 5 cancels with 4x plus 5, leaving us with the 25x squared. Our second grouping over here, 4x plus 5, cancels out with 4x plus 5, which leaves us with a 1. Remember, when everything cancels out, you are left with a 1. So what we're left with here are two different factors that we have that are getting multiplied, set equal to 0, that we need to continue to work with. So at this point here, we're going to use what is called the zero factor property, which says that if this factor times this factor equals 0, one of these factors has to be 0. So what we do is we assume that they both are, and we set each one of these factors equal to 0, and then solve those. So what that's going to look like is we're going to take 4x plus 5 and set that equal to 0. And then we're going to take the 25x squared plus 1 and set that equal to 0. And we're going to solve both of these equations here. Starting with the 4x plus 5, so this is just a basic linear equation here. So all we have to do here is subtract 5 on both sides to get 4x is equal to negative 5, and then dividing out the coefficient on both sides, we get that x is equal to a negative 5/4 as one of our solutions. Now I'm going to take this 25x squared and I'm going to move it over here so that I can work with this one here. So this one here is a quadratic equation because of that squared term right over there. And when it comes to working with quadratic equations, there's a few different ways that you could go about solving it here. You could try and factor it. You could technically put it into the quadratic formula and try a couple of different things like that. But I'm going to actually work with this equation here and solve it kind of the same way that I did this one over here. I'm going to start by subtracting the 1 on both sides to give me 25x squared is equal to a negative 1. Then I'm going to divide 25 on both sides to give me x squared is equal to a negative 1 over 25. At this point here, since we're solving for x, and this term here is squared, the way that you get rid of a squared term is by taking the square root of it. So I'm going to take the square root of x squared, which means I also need to take the square root of the right-hand side. On the left-hand side, square root and a square do cancel, leaving me with x. And on the right-hand side, so let's be a little bit careful here, we're taking the square root of a negative 1 over 25. So when you're taking the square root of a fraction, the quotient rule for radicals says that that square root can go to the numerator and it can also go to the denominator here. But there's also one thing that we need to watch out for here. In our numerator, we see that we're taking the square root of a negative 1. Now, if you remember this rule here, the square root of negative 1 is actually equal to I. We're going to get a complex answer for this part of the equation here. So that means our numerator is going to equal to I, and our denominator, we have the square root of 25, which we know is 5. And we know that when we take a square root, we have a positive and a negative version of that answer. So let's call this plus or minus I over 5. So that means that we have 3 solutions for this problem. And it makes sense because keep in mind when you're solving equations like this, always pay close attention to what the degree of that equation is. Our degree of this equation, our highest power is a 3. And that tells us that we should have 3 solutions to this equation. So our solutions are the negative 5/4, the positive I over 5, and then the negative I over 5 for our 3 solutions to that equation there. Otherwise, we're going to move on and let's work with example B. So example B is very similar to example A. Taking a look at example B, we have 1, 2, 3, 4 different terms in our equation. And we're going to go ahead and we're going to use factor by grouping to try and solve this equation as well. So that means I'm going to group together my first 2 terms, I'm going to group together my second 2 terms, and look for a greatest common factor of each one of those groupings. Taking a look at my first grouping, so I'm going to focus on the numbers first, 75 and 25. So when looking at 75 and 25 and coming up with the greatest common factor, that would look like 25. Out of x cubed and x squared, remember that it's going to be the lowest power out of the 2. So out of 3 and 2, 2 is the smallest. So our GCF for that grouping is 25x squared. So we're going to pull this out to the front, which means we need to divide each one of these terms by 25x squared to see what's going to go inside our parentheses here. When we divide, starting with our first grouping here, 75 divided by 25 gives us 3. X cubed over x squared, again keep the x, subtract your exponents, 3 minus 2 leaves us with 1. Minus 25 divided by 25 cancels, x squared divided by x squared cancels, leaving us with a 1. Similar situation over here on our second grouping here, the 3x minus 1. Looking for a GCF, we see that we don't have one here. Since 3 does not have anything in common with a 1, and they don't both have a variable with it, so we're actually just going to drop down the 3x minus 1. Which is actually fine because that happens to be what we have inside our parentheses for our first grouping. So we still have the 3x minus 1 in common. So then what we're going to do is we're going to pull out that 3x minus 1 to the front, and we're going to divide it out of each one of our groupings to see what we are left with. When we do this division, 3x minus 1 cancels with 3x minus 1, leaving us with 25x squared. And then 3x minus 1 cancels with 3x minus 1, leaving us with a positive 1 there. So here we're left with our two factors that equal to 0. So we can use the zero factor property once again that says that we can split up each one of our factors and set them each equal to 0 and solve. Solving our first equation here, all we have to do is add 1 to both sides for that one, and then divide out your coefficient of a 3 to get x is equal to a 1/3 there, okay, as our first solution. For our second equation, so again, I'm going to pull that up over here so I have just a little bit more room to work with. And if we can see here, we're pretty much left almost with this, or we are left with the same exact factor that we had in example A here, 25x squared plus 1. So we're going to solve it in the same way. Let's subtract that 1 on both sides, leaving us with 25x squared is equal to a negative 1. Let's divide out that 25 on both sides. That gives us x squared is equal to negative 1 over 25. And then our last step here in order to solve this here is take the square root of both sides because we're looking to get rid of that 2 here. So a square root and a square cancel, leaving us with x. And then we have the square root of negative 1 over 25. So again, remember to split that up between your numerator and your denominator so that you can simplify the radical. Remember that the square root of negative 1 is equal to an I, and the square root of 25 is equal to 5. And when we take a square root, we have a positive and a negative answer left there. So this is going to be plus or minus I over 5. So our three solutions for this equation here is the 1/3, the negative I over 5, and then the positive I over 5. Otherwise, that's it for this video.